Hi everyone, welcome. To detect whether carbon and hydrogen are present in organic compound or not, we went through Liebig's method in the last class. Now in this class, whether if one organic compound contain nitrogen, sulfur and halogen, right? In any organic compound along with carbon and hydrogen, other elements may also involve. If nitrogen or sulfur or halogen present in organic compound, how we can detect? So we have to go through Lassane's test. So the test is Lassane's test. Lassane's test, right? So by using this test, Lassane's test or sodium fusion extract test, this test is called Lassane's test or sodium fusion extract test. By using this Lassane's test, we can detect whether other elements other than carbon and hydrogen are present or not in a particular organic compound. We have to know by using this Lassane's test. Yes, so this Lassane's test also called as sodium fusion extract test. Okay, first of all, in this Lassane's test, I am taking one tube. So this is nothing but your fusion tube or ignition tube. Here I am taking one sodium metal, that is, this is nothing but your dry sodium. Now I am giving heat to this. So this is heat, right? I am giving heat to this. After this, again I am taking this sodium. Now along with sodium, in this tube only, I am taking one organic compound. I don't know initially which kind of organic compound it is. Means whether this organic compound contains nitrogen or sulfur or halogen. Which kind of organic compound, I don't know initially, but I am taking organic compound. First of all, I taken sodium and given heat. After that, after heating, again I am taking this organic compound along with sodium. Again I am heating this tube. Okay, so after heating, now I am taking one beaker. In this beaker, I have distilled water. This is distilled water, right? Now I am taking this total compound along with sodium out and placing into this beaker. I am taking this compound and placing into this. After placing, I am taking one pistol and doing paste, right? I am just stirring with this pistol. I am taking this organic compound and placing into this beaker, and I am just stirring with the pistol. And also I am giving heat here. So after this step, I am doing filtration. So after filtration, I will get sodium fusion extract. Right? So now here this sodium fusion extract, which kind of extract it is? It may be sodium cyanide extract or sodium sulfide extract or sodium halide extract. That means it may be sodium chloride, sodium bromide, sodium iodide. I don't know which kind of extract it is. Okay, it might be sodium cyanide, might be sodium sulfate or sodium halide extract. First of all, I have to know which kind of extract it is, right? Which kind of, for suppose if it is sodium cyanide extract, if I am getting sodium cyanide extract here, then here carbon and nitrogen is there, so my organic compound will also have nitrogen. If I get sodium sulfide extract, here sulfur is there, so my organic compound will have sulfur. If I will get sodium chloride, my organic compound will have chlorine. If I get sodium bromide, bromine. If I get sodium iodide, iodine will be there in the organic compound. So first of all, I have to confirm which type of extract, which kind of extract it is, right? Okay, now I'm getting extract here. I'm taking this extract again in one tube, right? I'm taking this sodium extract in one tube. To this tube, I'm adding FeSO4 solution. Listen carefully. I'm adding FeSO4 solution, ferrous sulfate solution. Ferrous is in +2 oxidation state here. X minus 2 equal to 0, X equal to +2. SO4 2 minus, right? I hope you people know how to find the oxidation state. So ferrous is in +2 oxidation state. Now after adding, what happens? See, first of all, here sodium extract is there. So here sodium extract is there. So here extract plus FeSO4, right? So one compound will form. I don't know which compound it is. One compound will form. After that, again I'm adding concentrated H2SO4 to this. Concentrated H2SO4 to this and heating. Okay, with the concentrated H2SO4, I'm heating this. What happens? This H2SO4, this concentrated H2SO4 will convert some of the Fe+2 to Fe+3. Okay, this concentrated H2SO4 will oxidize Fe+2 to Fe+3. Some of the Fe+2 ions to Fe+3. So these Fe+3 ions will react with this compound. Okay, with this obtaining compound. Now this compound reacting with this Fe+3 in presence of water, right? Reacting with Fe+3 to give another complex. If this complex obtaining complex is Prussian blue color, if this complex is Prussian blue color or green color, then my extract is sodium cyanide extract. Okay, again I'm repeating whole experiment. Listen clearly. First of all, I'm taking one tube. First of all, I'm taking sodium piece or sodium metal and heating. Okay, so after heating, again I'm taking desired organic compound. I have to find out which elements, whether nitrogen is present or not in this organic compound. I have to find out, right? I'm taking organic compound, again I'm heating, right? So after heating, I'm taking total organic compound along with sodium into this beaker. This beaker contains distilled water. I'm crushing this organic compound with one pistol and again heating. So after heating, I'm filtering this. So after filtration, I'm getting one sodium fusion extract. Initially, I don't know which kind of extract it is. If I will get sodium cyanide extract, then my compound will have nitrogen. So to confirm this, to confirm which kind of extract it is, to know which kind of extract it is, I'm taking one tube here. In this tube, I'm taking this extract, this sodium fusion extract I'm taking here. So to this extract, I'm adding FeSO4 solution, freshly prepared ferrous sulfate solution I'm adding. So after adding freshly prepared ferrous sulfate solution, I'm getting one compound. Okay, to this tube only, I'm adding concentrated H2SO4 solution. This H2SO4 will oxidize this ferrous +2 to ferrous +3. This ferrous +3 is reacting with this obtained compound to give one complex. This complex, if this complex appear as Prussian blue color or green color, then it is confirming that my extract is sodium cyanide. If my extract is sodium cyanide, my organic compound will have carbon and nitrogen. So this is the whole experiment. This is whole experiment. See, You don't need to remember this whole experiment. Just to understand, I have given the explanation. What you have to remember. See, first of all, what you have to remember. You have to remember only reactions. You don't need to remember total experiment. देखो. So I am writing just these reactions here. First of all, to prepare this extract, what we have done, what you did. See, first of all, I am taking sodium. Okay, so in chew, I taken sodium. Again, organic compound. So organic compound contains carbon and nitrogen, because already it is confirmed that sodium cyanide is there. Okay, by appearing this Prussian blue, it is confirmed that sodium cyanide is there. That means my organic compound contains carbon and nitrogen. So first step, first reaction is sodium, carbon, nitrogen. I am heating sodium cyanide. Okay, sodium cyanide. This is the sodium cyanide extract I am getting. This is the first step. Second step, I am taking sodium cyanide extract, adding FeSO4 solution, right? So sodium cyanide extract, FeSO4 solution. So in this FeSO4, Fe plus 2 ions are there. So Cn minus, 6 Cn minus, from this sodium cyanide 6 Cn minus, and from this FeSO4 I am taking Fe plus 2, right? Okay. So whenever this extract is reacting with FeSO4, I am getting one compound here, right? So this compound is nothing but sodium hexacyanoferrate 3, FeCN 6 times minus 4. So this compound has been obtained, right? So this is the compound. Now to this compound, what happens? After adding H2SO4, some of the Fe plus 2 ions will be converted to Fe plus 3. Now this compound will react with this Fe plus 3 and water. This compound is reacting with Fe plus 3 and X moles of water. Okay, so now I am getting one complex. Okay, complex with the color of Prussian blue. What is that complex? You have to remember these complexes: Fe4, FeCN 6 times whole thrice XH2O, right? I am writing the same compound, same complex here. देखो, I am getting this complex Fe4, FeCN 6 times thrice XH2. Okay, so this is the color of this complex is Prussian blue, or green color, So you have to remember these reactions only. This reaction is important and this reaction is important. So only thing, you have to remember the experiment just to understand more clearly, but you have to remember these reactions only. So you are getting, finally you are getting Prussian blue color, so that it confirms, this Prussian blue color confirms that you have sodium cyanide extract. When you have sodium cyanide extract, that means in your organic compound carbon and nitrogen are there. Okay, this confirms that your organic compound has nitrogen, right? So this is the process of the detection of nitrogen, right? So this is about the today's class. Thank you so much for watching.